Let us solve some more sums. Find the HCF or the GCD of 25 and 33 by listing the factors method. So we're going to list down the factors of 25, and the factors of 33. So we know it goes in the table of 1 and 25 itself. Then this does not go in the table of 2, this does not go in the table of 3, 2 plus 5 is 7. Does not go in the table of 4, then it goes in the table of 5. 5 5s is 25. So the only factors are 1, 5 and 25. What about 33? 33 goes in the table of 1 in itself, which is 33. And it goes in the table of 3, not 2. 3 11s are 33. And then it does not go in any other table. So the only factors of 33 are 1, 3, 11 and 33. So we are going to write down the common factors. Which factors are common to both the list? Yes, of course, 1 is common and no other number. Okay, so only there is one common factor. So that is itself the highest common factor. So the highest common factor of 25 and 33 is 1. Also note that when the highest common factor of two numbers is 1, they are also called co-prime numbers. So whatever happens, we'll have at least one common factor, and that is 1. Let's take another example. Find the HCF or the GCD of 150, 200, 225 and 75 by prime factorization. So we are going to find the HCF of 4 numbers, 150, then 200, then 225 and then 75 also. So let's start with 150. We are going to find all the prime factors. It goes in the table of 2. So we have 2 7s are 14, 1 carry, 2 5s are 10. Then it goes in the table of 5, but before that 7 plus 5 is 12. It also goes in the table of 3. Of course, we can also write 5, but let's start with 3. 3 3s are 9, so 3 2s are 6, 1 carry, 3 5s are 15. Then we have 5 5s are 25, 5 1s are 5. So the factors are 2, 3, 5, 5. In the same manner, we're going to write down the factors of 200. So the factors of 200 are 2 100s are, 2 50s are. So whenever we are dividing any number by 2, we actually half it. So 2 25s are, and then we have 5 5s are and 5 1s are. So we have 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 5. Now let's solve for 225. 2 2 5. It does not go in the table of 2 because it is an odd number. So 2 plus 2 is 4, 4 plus 5 is 9, it is divisible by 3. So 3, and we'll take these two numbers together. 3 7s are 21. Then we have 1, 15, 3 5s are 15. Then we have 3 again, 3 2s are 6, 3 5s are 50. Then we have 5 5s are 25 and 5 1s are 5. So we have 3 multiplied by 3 multiplied by 5 multiplied by 5. And finally 75. So if you just ignore these numbers, we have the factors of 75 before us. And the factors of 75 are 3, 5 and 5. So first of all, we are going to find the factors or the numbers that are common to all of them. So we can directly write the highest common factor over here. And we are going to list down all the numbers that are common to all the 3 lists. For example, we have 2 over here, but 2 is absent in this one. So 2 is not a common factor. What about 3? 3 is not present in 200. So what about 5? Yeah, 5 is present in all the lists. So we have the first number as 5. And what about the other 5? Yeah, it is present in all the 4. So we have one more 5. So the highest common factor is 5 5s are 25. So 150, 200, 225 and 75 all are divisible by 25. For instance, 25 6s are 150. Then we have 25 8s are 200. 2 into 2 into 2 is 8. And then we have 25 9s are 225. 9 comes from here. And then we have 25 3s are 75. So 25 is the biggest possible number that is present in 150, 200, 225 and 75. Find the HCF or the GCD of 81 and 99 by division method. So in order to do the division, we are going to write the bigger number inside and the smaller number outside. So we have 81 and 99. 99 divided by 81. So 81 ones are 81. 9 minus 1 is 8. 9 minus 8 is 1. Then we are going to write down this 18 as a divisor and this 81 as the dividend. So there's a shorthand of writing the same. So 81 divided by 18. So we need to know the table of 18 for that. We have 18 ones are 18, 18 twos are 36. If you add these two, we'll get 18 threes are. So 8 plus 6 is 14, 1 carry, 3, 4, 5. We have 18 threes are 54. And if you add 18 and 54, you'll get 18 fours are. So 8 plus 4 is 12, 1 carry, 5, 6, 7, 18 fours are 72. And I believe then 18 fives will become a little bigger. So 18 fours are 72. So let's subtract this. 11 minus 2 is 9 and 7 minus 7 is 0. And since we did not get a remainder of 0, we are going to continue with this. So now our remainder 9 is the new divisor and our old divisor 18 is our dividend. And let us continue this. 9 twos are 18. And since now we get a remainder of 0, this divisor is our HCF. So we can write HCF of 81 and 99 is 9. And finally, find the HCF or the GCD of 120 and 144 by taking away the least. Taking away the least means subtract the smaller number, the least number of all the other numbers. And 120 and 144, 120 is smaller. So we are going to bring down 120 as it is. And we are going to subtract 120 from this number. So we have 4, then we have 2, and we have a 0. Now what we are going to do, we are going to compare these two numbers. And 24 is a smaller number. So we are going to subtract 24 from 120 and bring down the 24 as it is. So we have 10 minus 4 is 6 and 11 minus 2 is 9. So we have 96 and 24 and compare them. 24 is smaller, so take away 24 from 96 and we have 72 and bring down the 24 as it is. Do not subtract 24 from 24, otherwise you'll get a 0. And again 24 is smaller, so take away 24 from 72. This is very similar to the division method, in fact, almost like the division method itself. So 12 minus 4 is 8 and 6 minus 2 is 4. And bring down the 24 as it is and take away 24 from 48 and you'll get a 24 and bring down the 24. And now both the numbers are equal, so this is the HCF. So the HCF is 24. Thank you for watching this video.